Hi everyone, welcome. I'm super excited to be here and delivering this session for Dev3Con. Today's session will be about how to build data streams for your AI applications, or another word, live data and smarter AI. Merry Christmas, joyful greetings from me. Let me introduce myself. My name is Babur, or you can call me the Tiger, which is in English. I am a developer, advocate, and also ex-Microsoft employee and Apache Software Foundation committer. I like to contribute open source project and contribute to blogging and writing about all the open source tools. Feel free to connect me on LinkedIn if you have any questions regarding my session. I will be more than happy to answer and address your questions, or just we can jump on call with a cup of coffee and discuss more interesting facts. Here's the agenda for today. We'll start with discussing some of the GPT limitations, LLM model limitations, and I will also walk you through the common solutions nowadays to use in context learning for your AI applications, or how to add private data to your LLM applications. And I'm also going to introduce you our open source project called LLM App, large language model app, and what are the key features, what you can achieve with that, and how it works. I will briefly describe, and at the end you will see the demo of LLM application without vector storages or like vector databases, which provides a simple infrastructure for your applications. So everyone is talking about AI or artificial intelligence nowadays, but much of that talks falls into one of two extremes, right? AI will fix everything, or AI will ruin everything. But we'll see in the next 3 years or 5 years what AI brings to which world us. And but in general, large language models nowadays can be used to or applied to variety of use cases and industries. Correct? I mean, nowadays, for example, going through the enormous documents of records such as legal papers, academic studies, news, or technical guides can be fully automated using these LLMs. You can take an example of OpenAI GPT-4, very powerful LLM, used a wide range of tasks, NLP tasks, and for example, ChatGPT sets a record for the fastest growing user base in January 2023, proving that language models are going to stay here longer. It's not anymore like a hype topic we faced in the past, like a blockchain or the Web3 technologies, basically. And as a developer, I also decided to build my own AI applications. What about quickly summarizing the content and get the information you need in real time from private, large, unstructured documents in your Dropbox? And the same tool can be used with OneDrive or maybe the Google Drive, so I can search for specific data from multiple PDFs, because sometimes it's quite hard to find out and PDFs by using these search engine tools. Or another example, you can build AI application that I was able to also build to find real-time discounts, deals, sales, coupons, prices from various online markets around the world, such as Amazon products, for example. I can search for Nike shoes by providing my size and additional information to AI and natural languages, so it can search for specific the discounts from these online markets. Or last one but not least one, think about LLM application that provides real-time alerts for significant change or updates in your marketing campaigns. This system can monitor various aspects such as content change, maybe campaign performance metrics, audience engagement, or maybe budget alterations. So real-time alerts enables marketing teams to respond quickly to that changes. It makes campaigns remain on track, optimized for the performance. Or you can also use the same for other use cases. Here I am providing a list of showcases I was able to create using LLM, and the open source project I'm going to introduce you to soon. Feel free to go through the link at the end of this slide and to try yourself on the GitHub repository and run one of these example projects. You'll find them very interesting. For example, the same alerting example can help you to remove some partially the hallucination, which is a word of the year this year. And LLM Apps alerting feature can be used for monitoring model performance. For example, when LLMs can occasionally produce unexpected, undesirable outputs. So in case there are also LLMs alerting, you can be used for processing sensitive data, like real-time alerting can be leveraged for security and compliance cases too. If you would like to see the system can identify, let's say, hallucination level, and then it can send you the alert if the model responding not accurately. But while I was developing these applications, I faced with some obvious issues because of GPT limitations. As you can see, because GPT trained not with events maybe before September 2021, but now actually GPT-4 is updated and it's January 2022, but you cannot ask question based on your private data, or you cannot get the information from the past conversation. The same ChatGPT interface, it provides separate sessions for each the user session to keep the history, but if you jump from one session to another, you will lose the questions or the context being asked in the previous session. We can test it. Let's try to find some discounts in the example of discounts application this week for Adidas and men's shoes. What I'm interested, because here is keywords like this week and Adidas, which is also very direct discounts searching. Operation should be done. If you ask these questions, obviously GPT offer general advice on locating discounts, but it lacks specificity regarding where and what type of discounts, among other details, we are missing. So to help the GPT, we apply prompt engineering, which is a very famous nowadays. Even software engineers they are learning how to properly make a prompt engineering now, and we supplement with discounts information from some data sources to put as input data to make a GPT context aware when we ask some questions, and before asking the question we just putting some initial document to the AI. So what I did, I'm using the same GPT interface, and I just extracted JSON response from real Amazon product API, and I put into the GPT interface. Now you get an expected output, obvious, because this is quite simple to achieve with ChatGPT. Now it knows where to get this knowledge. However, this issue with this method, the model's context is restricted. For example, GPT-4 maximum text length around 8,192 tokens. This strategy will quickly become problematic when input data is huge. You may expect thousands of items discovered in real cells, and you cannot provide this large amount of data as input message. So it's not at all. We have other problems as well, as we have seen in some manual work, and it has a limited context and you cannot save the data for the future. But more startup projects nowadays are challenging on productionizing the ChatGPT solutions. It's very easy to make something cool with LLMs, but very hard to make something production ready with them. In addition to language ambiguity problems, the most important problems we should consider is cost, because by providing more detailed information, examples, the model's performance might improve, but at higher cost. For example, if you're using GPT-4 with input of 10k tokens and output of 200 tokens, the cost will be 0.6 per prediction. If you're sending repeatedly the same identical request, this escalates the cost unless if you're using any local cache system. Or what about like latency? And one of the challenges is OpenAI, for example, as a provider, they don't have a SLA, which means they don't have a guarantee regarding of the how long it takes AI or LLM model to respond to your request. You never know approximately when your request comes to your system back when you ask a question. And another issue, like security, when integrating, for example, custom plugins into ChatGPT, every API endpoint must be specified in Open API specification. If you read the plugins documentation and the OpenAI website, this means you are revealing your internal API setup to ChatGPT, which is pretty much risk for many enterprises. And now enterprises are not considering at all this custom plugins to call the APIs intelligently. So, and the last but not least is offline evaluation, conducting, for example, offline tests on your code or data output, or replicating the same data flow locally is challenging for developers. For example, this is because each request to the system may yield varying response. You will get different responses when you ask the same question each time. So there are many challenges which are not listed on this slide as well, but now we will focus on more on this session how we can solve not all the problems, but the problems at least like partially using some other approach. So first of all, how you add your own data by using ChatGPT interface. We also tried manually or using custom plugins. Another way is using APIs. Because the OpenAI API, if you take as a public provider, it provides two famous endpoints, which is also called RAG approach, retrieval augmented generation, which has an approach you call first embedding endpoints to calculate some vector embeddings, and you create a prompt based on the similarity search operation. I'm going to explain how this works. If you know on using these APIs, you can already understand like what is a common architecture looks like. As you can see, is nowadays every applications building based on this RAG architecture. It's like a building data pipeline. As you can see, on the left side there are some APIs, files and databases sending the data or ingesting data to our system as a data source, and we build a data pipeline to pre-process, filter, and maybe remove some sensitive data before sending this data for vector embeddings to the embeddings endpoint from OpenAI. So in this case, we calculate first vector embeddings from input data, and then we storage this calculated vector embeddings to some sort of storage we call the vector databases by their indexes. So for those who doesn't know what's vector embeddings, it's very simple also to understand. You may think about like two vectors where two vectors are close, which means two content very related to each other. If the distance between two vectors are very long, which means these texts are not related to each other. So basically OpenAI helps us to calculate these vector embeddings. And once we store indexed vector embeddings, we start to build our AI applications with small search bar and backend service, and we accept user queries by asking, for example, show me the discounts. Based on what being asked in the query, we again calculate the vector embeddings using OpenAI API embeddings endpoint. We do similarity search from the storage, or we previously stored the vector embeddings, and if there is a match, we start to create a prompt to send the chat completion endpoint this prompt, like asking, given that this input data and user query, please answer this question. In this case, we will more detailedly asking the GPT or the LLM model to find or retrieve a very specific information. So hopefully this simple architecture is clear to you. But when it comes to building and realizing this architecture, things becomes even complex, because you need to use multiple frameworks, technologies. If you look at this diagram, emerging LLM app stack, you can see lots of moving parts, lots of open source, non-open source technologies you need to use to make a proper AI applications. Like you need to use some cache, you need to use some LLM frameworks like a LangChain or Lambda Index and so on. But with our team, starting August 2023, we decided to make this operation even simpler by offering developers one single platform. Basically, we combine two technologies together. We had the Pathway open source project, which is an application layer for both batch and streaming data processing, like Flink or Spark, but with the higher speed and higher performance. And we combined it with LLM App framework, which is also in Python, that helps developers to build AI applications without complex infrastructure. And when you combine these technologies, of course, you will get your AI data pipelines that runs in real time. So what does it gives you in terms of development and bringing your AI application to the prod? It means it's a short time to go to market. You spend only from 4 to 6 weeks to develop your new application from scratch with lower costs, because you are not using vector databases, which is also comes with a cost when you are deploying to on-prem or the cloud. Also, another is security. You are not exposing your data to other storages, because your data stays where it is, like inside the PostgreSQL or the MySQL, any existing OLTP databases. And our computation layer in Pathway runs on the top of it. And it's also very easy to adopt. You don't have to go through the complex learning passes, like to learn every new technology that using LLM application, because our open source project abstracts all these the complex technologies into one platform. So, and what also you can ingest is you can ingest different types of data: unstructured, structured, semi-structured, even live data. You can connect maybe your data to streaming data sources like Kafka or Redpanda to get to train the AI with real-time information. And what about the future? So nowadays we are providing features for open source, features for enterprise, even the features for open source highly on demand, like session replay, for example. The same code you can reuse for your offline testing. Perhaps you don't have to use run application costly for your tests that use, for example, OpenAI or Azure OpenAI endpoints. We can use private LLM models that are perfect for your unit testing, for example, or integration testing. And of course, we have this alerting feature where you can automatically compare the answer from the model previously and currently to get a better data information based on both historical and present data. And another feature that I like is user permissions. For example, AI should be able to identify the roles of your user. Let's say we have in our company salary review process every 3 months, and my manager would like to see my the performance for the last 3 months, but only my manager able to see my performance review, but not other employees. Otherwise, like people, if my colleague knows about information about me from AI, about my salary, it will be a little bit of a discussion. So in this case, with using LLM app, you can provide some metadata and user roles information. So in the response, it automatically filters out unnecessary data that is the current role is not able to see or not allowed to see. And of course, we are also providing local machine learning models that runs using your infrastructure. You don't have to use public API LLM providers like OpenAI. You can run your well-trained, fine-tuned LLMs locally. From the architecture perspective, if you compare the previous emerging LLM stack, we have a simple architecture. Take a find me discounts application. It looks now is very simple. We have a UI and backend application. UI you can build using any front-end application, using maybe JavaScript frameworks of Streamlit in Python. Streamlit I like because I'm a backend developer. Without having a knowledge in front-end, the Streamlit helps me to create some HTML or CSS designs. And as you can see, this orange box inside is a pathway where are some components, and each component can be customized by depending on your requirements. For example, you can use natural features or machine learning features, or maybe in-memory search index can be achieved inside this model. Of course, also on the top of you will get real-time prompting and a control layer which responds in real time to requests and replies. And of course, we can use multiple LLMs, like not only OpenAI, maybe Hugging Face or LLM models to combine multiple responses. From the code-wise, if you look at this Python code, it requires only you to write 30 lines of code. Like you first show what kind of data source you are ingesting or what kind of data you are providing to your AI application. For example, if you reading a CSV data, for example, you first this document will be transformed to structured documents, and we chunk these documents to send these chunks to vector embeddings endpoints from OpenAI. Once we do embeddings, we index these embeddings using some algorithms like using KNN, key neighbors algorithm to find out which is similar, which vector is similar to another vector, and we, let's say, accept some API calls from the UI, like because there's a REST controller connector from the pathway, so we can expect some streaming calls from UI and send the streaming response back to the UI as well, like how the fast API works. And once the user query comes in, we again doing embeddings and we build a prompt, and then after we get a prompt response from chat completion endpoint, we are just sending back to the UI application, and all the magic happening on the bottom line. It's called the run the pipeline, like pathway.run method, pw.run makes this routine like a loop. This code, every time user query comes in, we do real-time indexing and provide the real-time AI response. The same as with large amount of data. Assume that we have PDFs of 100 pages. After you upload, you don't have to wait your application that this PDF is being processed. You can immediately start to use application without any waiting, because we are talking about real-time indexing and updating. So here's one of the examples of how you can build a data processing pipeline with Pathway. It's like manipulating static and finite data. Then when you get really big data, you can easily switch to streaming mode, and Pathway can manage all the updates for you. As you can see here in this example, we are reading some CSV data with numbers, and we are using simple transform function like reduce, and which the code was in static mode. Now easily we can just change one line of code or one setup in the code, like converting mode from static and streaming. That makes the application already running in streaming mode. So what does it mean for your code in building this data processing pipeline using pathway in Python? In practice, you need to use provided built-in connectors to plug the pathway over your data streams. For example, maybe using the Bayesian, Kafka, some data storages like AWS S3 or Azure Blob Storage or even Azure Event Hubs. You can connect data sources and you build your pipeline only once, and you don't have to rebuild it again if you would like to make this pipeline run both in batch processing or stream processing. If you're interested in contributing or looking at the LLM app repository, GitHub repository, here I am leaving out the QR code. Please scan the QR code and start to analyze and discover our showcases to learn. And also we are growing. Starting from August, we are gaining some more folks, GitHub stars. If you find it interesting, please put your stars. It will help us to grow even further in building applications, developer tools for AI developers, make this life more easier. With some theoretical knowledge in mind, now we can jump into practical session, which is a demo. I'm going to show you this Dropbox AI assistant retrieval or the content retrieval using the LLMs. I'm using the GitHub repository. If you scan this QR code on this slide, it will bring you to GitHub repository. Here we go. Here in the GitHub repository called Dropbox AI chat. You can have a look at the repository folders. Basically, you can run this application using the multiple ways, running it with Docker, or you can run it from the source, or you can run also using the Conda if you're following the video tutorial here. What I am going to do, I'm simply running the application by Docker. After you clone and open the project in your favorite editor, in my case I'm just using the VS Code. Here you will find some of the code folders like for API and also for the UI application. For the UI application, looks like very simple because you are using Streamlit with just one the search box where the users can give and provide some input, and a basic application code lies inside the api.python file. You can also check, it's also very simple, that you use the pathway LLM application framework. What I did, I did Docker compose app, I ran my application, and as you can see on my Docker desktop, both backend and front-end applications are up and running. If you navigate to the front-end UI side, Streamlit application, it will bring you to the localhost 8501 port where our Dropbox source tool up and running. Now let's test how this AI source tool can help us to find the information we need from the Dropbox. What I do, let's say from a collaborative team working document folder where the people or team member are accessing Dropbox from different machines, from of course different browsers. Let's assume that your colleague uploads Dropbox some documents, or you upload from another machine, maybe from the same machine some documents. Because I am a developer advocate, I travel a lot, I go to conferences, I like to I want that my AI application provides some insights about my expenses from multiple documents, like a document from booking.com or electronic ticket I buy for the flights, or maybe there's some expense details for the taxi like a Bolt. So after I upload, if you come back to the Streamlit, you can, for example, ask questions. It helps me to find some maybe expenses. I can ask, show me all expenses from documents. If you ask this question, AI should summarize my expenses from these multiple unstructured PDF documents. In this case, based on the speed of the internet connection and the model you are using, you will get the answer something like this. As you can see, it even categorizes the details like for booking or invoices and which flight. So in this case, I can easily retrieve the information from multiple documents. That's how the shortly Dropbox search tool works. I leave it to you to observe more this GitHub repository. If you like it, please help us with your GitHub stars, or you can start to build it by forking the application. Last showcase I would like to show you is data streaming for AI application using the Pathway and Kafka, like Azure Event Hubs, Azure OpenAI, also Azure Cosmos DB, how we can combine these technologies in the cloud with the Pathway to build some data streaming processing for our AI applications. As you can see, this is the Azure infrastructural architectural diagram. I have both unstructured data on the bottom and on the top semi-structured data, which are Kafka topics, maybe in JSON. And let's assume that this is an AI-driven flight management application or reservation application. What I would like to achieve in this application, I have a front end like on Streamlit that provides some features like the chatbot. Like I can say to this chatbot, please alert me when the flight status changes. And then this alerting mechanism enabled by using the LLM application on the Pathway side. So whenever some flight updates or airline policy updates comes in as a Kafka events, the Pathway can analyze in real time and do similarity search. So connect to the Azure OpenAI to find out the relevant vector embeddings and do some the chat completion. So in this case, if the flight status changes, like to cancel it or rebook it, it uses both information from the input data, I'm saying maybe it's Azure Blob Storage, where a lot of data files exists, like a long list of airline policies, and we should be able to alert the user when the flight status changes by sending the alert message to messaging service, like maybe in Azure or maybe outside Azure. We can send some SMS message or alert on the Slack. And also at the same time, if the flight status changes, we need to also update this new booking entries or cancellation information in the Azure Cosmos DB, because Azure Cosmos DB can be accessed by external services, where Booking.com, for example, can use the Azure Cosmos DB to read the updated data or to manage this updated data. So basically, this architecture demonstrates this enterprise AI solution that's able to create some alerts in real time and also combine semi-structured and unstructured data using LLMs. Let me show you how it works. I have already successfully deployed it to the cloud. It's up and running on Azure. Assume that both front-end and back-end application are running in Azure. Now, if I navigate to front-end application, which is running inside the container app, and back-end application also running in container app, I can show you here just a simple resource group with multiple components using also Azure OpenAI. On the front-end side, it's running in this link, and it opens like a real-time notifications application with LLMs. Now I can also ask this LLM application like similarly alert me. I can say alert me when the flight status changes. So, and in this case, when it will automatically creates alert for the flight changes. As you can see, it's based on the current information coming from Kafka events. It is already notifying us, okay, the flight status of your current is delayed due to technical issues. And I also connected this alerting mechanism to messaging service like Slack. You will get also on Slack the same response, the alerting message immediately, like with the additional flight status delete information. And here, another magic, you can add also airline policies, some rules that being affected by this flight delete or flight rebooking change. So with that, I hope you found my showcases quite inspiring. Now, last words about the pathway, when you can use the pathway and how the people think about pathway. If you want, you can use the pathway if you like to fix your latency issues, because you are running some sort of batch job operation that runs hours or days, so you can reduce this latency to even the milliseconds. And also it reduces your compute bills if you're running your application in the cloud, because the cloud bill is too high when you're using like batch processing tools or other stream processing tools like Spark. As you can see, I was able to deploy my pathway application to container app, which is container app also compared to the storage batch processing applications much cheaper. And also, if you would like to build your real-time application just in a single day, the pathway is good to go, because you don't have to create some complex clusters. You just start to implement your code inside a single instance by adding the Python libraries to your the project. And of course, it also improves your team's collaboration, because some teams in some companies, they have separate team for batch processing and stream processing, so you don't have to hire or have skills in both directions if you're using the pathway. Here are some of the takeaways from my session, and you can always automate the knowledge insertion to your AI application, as we have seen, using the embeddings or chat completion APIs, or maybe in the future using multiple API providers, or maybe your private API providers. You can use the pathway framework to unify the complexity into one platform, and also you can use the LLM application to build LLM-enabled data pipelines for your real-time data. Thank you for attending my session. If you would like to connect with me and have questions, please ping me on LinkedIn. I will be available, or you can find me also on Twitter, or you can maybe also see my other GitHub repository on GitHub. Merry Christmas. I hope you receive one blessing after another this coming year. Wishing you happy holidays and new year coming 2024 that makes you smile every day. Thanks. Bye bye.